The first two graphs we're going to talk about are sine and cosine. Kind of the two basic graphs here. And what you have here are just the basic graphs of sine and cosine, or what I would say is one phase of sine and cosine. If you graph sine and cosine on your calculator, you'll notice it's not just this short little graph, but it keeps going on and on forever and ever in both directions. And I don't know how much you guys remember when we did, what was it, lesson 1.3, and we had that page of 12 graphs. Sine and cosine were two of those graphs, weren't they? And they keep going up and down, but it keeps going on infinitely. What we're looking at graphing is just one phase of it here. And so with sine, first of all, with sine and cosine, you'll notice the range is -1 to 1 on just our traditional graph. And we're going to look at what happens when we graph these. You need to know the basic graph, but then we're going to look at different, basically our translations, our reflections, our stretch and shrink. We're going to kind of look at those things, but in some pre-calc terms here, trig terms. So, okay, so sine graph is always a graph that oscillates, if I can use that word, between -1 and 1. So it never goes higher than 1 or lower than -1, unless, of course, it's moved. It starts your graph at 0, 0, and one phase of it ends at 2 pi. So a phase or a period of sine and cosine is 2 pi. Just like once around the unit circle is 2 pi, one period or phase is 2 pi. With this, you'll notice that you start at 0, 0. There's a max above pi over 2 up at 1. At pi, it crosses the x-axis again. At 3 pi over 2, there's a minimum at -1. And at 2 pi, it is at 0 again. Okay. In terms of cosine, technically, cosine is just a sine graph that is shifted left or right. Okay. It's the same graph. It just looks different when we're just looking at one period or phase of it. So here, it starts up at 0, 1, crosses down through pi over 2, has a minimum below pi, crosses back up through 3 pi over 2, and has a maximum at 2 pi. And it would just keep going on and on if we went past that. Now, a connection I don't usually make at this point, but I think I'm going to try it this year. Think about your quadrantal angles with me. Okay, so this is 0, this is pi over 2, pi, 3 pi over 2, and 0 is also the same as 2 pi, correct? Now think about the ordered pairs. Like if we're trying to find, say, the sine or cosine of pi over 2. What is the ordered pair here on the unit circle? Left or right 0 and up 1? Over at pi, what is this ordered pair? On the unit circle, it's left 1, up or down 0. At 3 pi over 2, it's left or right 0 and down 1. And you could call this 0, you could call this 2 pi. It is what? Right 1, up or down 0. What do these ordered pairs represent? They are what kind of values? They are the cosine and sine values, correct? Okay, so here's the connection I want to make with you. What is the sine at 0? The sine at 0 is at the y value of 0, yes? Right here, what is the sine at 0? The sine at 0 is 0. Okay, what about pi over 2? What is the sine at pi over 2? It's 1. What do you notice right here? What is the sine? Where is this graph at pi over 2? 0, 1. Okay, so these points are matching up, is what I'm trying to tell you. Over at pi, my sign is 0. Notice that's a 0. At 3 pi over 2, my sign is at -1. And back at 2 pi, my sign is at 0. So there's kind of a connection as we work, as we have to find the sine and cosine of those specific pieces. There's kind of a connection there that I wanted to try and establish. I don't know if you like that connection or not, but the same is true for cosine. The cosine at 0 is at 1. Cosine at 0 is at 1. Cosine at pi over 2 is 0. Cosine at pi is down at -1. Cosine at pi is -1. Cosine of 3 pi over 2 is 0. Cosine of 3 pi over 2 is 0. Cosine of 2 pi is up at 1. Cosine at 2 pi is up at 1. So there is that connection there between how I traditionally have had you find sine and cosine of those quadrantal angles and how you can also connect with the graph. Okay? So we'll work with these graphs lots. Some of you guys are going to like this next week or two as we're graphing these. Some of you are not going to be crazy about it, but it's more about hitting the key points here and knowing how they relate. Okay, as you look down here, this y equals a sine of bx minus c plus d, or a cosine of bx minus c plus d. Those are the pieces that kind of tell us what is this graph doing. Because we're not just graphing sine and cosine, we're manipulating the graph. We're shifting it, we're stretching it, we're reflecting it. All those types of pieces. So, the absolute value of a. So notice a being the number out in front of sine or cosine. Well, what normally, if you're multiplying by something, what does that normally do to a graph? It's going to stretch it or shrink it, yes? And so right here, when we talk about a being the amplitude, it's how far above and below the center line to count. It is your, if you want to relate back to what we did in algebra last year, it is your vertical, shrink, and stretch. Okay? So in this case, normally a traditional sine and cosine graph goes up to 1 and down to -1. If there's a stretch or shrink, it might go farther, it might go less. But that will be your a value, your amplitude. Okay? This next piece says 2 pi over b. And 2 pi over b is the period, the length of one cycle of sine or cosine. So the traditional length of one cycle is 2 pi. If there's a b value, notice b is the coefficient of x. That will give you how that period changes. So this is your horizontal shrink or stretch. So when that value is multiplied directly by x, it's going to affect, is this graph longer? Is it shorter? So this is your horizontal shrink and stretch. C over B is listed as your phase shift. This will put your graph in the correct location. Notice C over B are the pieces inside the parentheses with the x, yes? And so that C over B is going to be your horizontal translation. Okay, how far we're going to go left or right. So again, just trying to relate it a little bit to last year. But that is your horizontal translation. Okay. D, your value at the end. Notice the plus D is at the end here, right? It's added or subtracted outside, away from the x. So in algebra, that was how far we move the graph up or down. So your vertical translation, you'll notice here it calls center line, because what we do is we're going to change our center line. So we don't have to move the graph up and try and graph with nothing there. We're going to change our center line. But this relates to your vertical translation. So how far up or down the graph moves. And then a negative a. What's a negative out in front of the equation going to mean? Notice there it says a negative a means to flip the graph. This is your reflection. Okay. Do we make the sine or cosine graph what it looks like up above? Or do we have to flip it upside down? Okay. So, those are all the pieces. And we're going to work on applying those. Okay, I'm going to take you through and kind of show you some examples. These will relate to the examples in the homework as to how we can apply all the details here. Some of them are a little easier than others. Some of them will take a little bit of time to adjust. Okay, ready? Our first example is y equals 3. No, I'm in the middle of teaching. I don't want you to shut down. What? Okay, crazy speak here. Y equals 3 sine of x minus 4. So, first of all, what is the sum graphing? I know it's a silly question, but it helps to ask. What is the sum graphing? This is sine, yes? If you look up top, what does a sine graph look like? Starts at the center and what? Has a mountain and a valley, if you will. Okay, so just to kind of give myself a visual, when I graph my sine, I know it's going to look like that, right? It's going to start in the center, mountain and valley. Okay, so that's just, me trying to visualize it. Okay, let's see. Things I like to ask myself. And I like to write down all the information over here to organize. And then we'll graph. Center line. Where's my center line going to be? Look back at the top of your notes. Center line is represented by D. And what is my D value here? -4. So my center line is going to be at -4. So basically this graph is moved down 4. What we're going to do though is we're going to relabel that x-axis, instead of making that x-axis 0, we're going to relabel that as our center line of -4. Okay? Let's talk about our amplitude. Amplitude is represented by the A value, correct? Sorry, I forget what the letters are sometimes. I just know where they're at. What's my A value? What's my amplitude here? 3. Okay, so an amplitude of 3 basically is a stretch. Okay, instead of my graph going 1 up from the center and 1 down from the center, we're going to stretch that. And we're going to go 3 up from the center and 3 down from the center. Okay. We always need to talk about the period. How long is our graph going to be? And what's the formula for period? 2 pi over b. So it's always 2 pi divided by b. What is my b in this case? 1, right? B is the coefficient on x, the number on x. So B is 1, so 2 pi divided by 1 is 2 pi. So our graph is our normal basic 2 pi, nothing fancy here. Okay, so this is going to be just one cycle. Okay, amplitude up here is how high and low the graph goes, if that helps. Now let's see, we've talked about amplitude, period, phase shift. I'm not going to worry about phase shift because what is there not in this particular problem? There's no c, right? There's nothing added or subtracted on x, so I don't have to worry about a phase shift. I'll only worry about phase shift when there's something added or subtracted in those parentheses. And then there's no negative out front, so no reflection. Okay, ready to try this? I would say a big portion of success here is getting everything labeled correctly. My center line is going to be what? -4. So instead of my x-axis representing 0, my x-axis is going to represent -4. You can label it -4 there, or what I end up doing is labeling it -4 there at what is traditionally the origin. Instead of being 0, 0, that's 0, -4 now. So always label your center line. And then I usually label my amplitude next. Amplitude of 3. So that says it's a stretch of 3. Instead of going 1 up from the center and 1 down from the center, I'm going to go 3 up from the center and 3 down from the center. So my high point is going to count 3 up here and 3 down there. What would be my highest point and my lowest point represented based on the fact my center line is -4? I agree. Does that make sense? Because 3 up from -4 is -1, and 3 down from -4 is -7. You don't have to label all the betweens if you don't want to. If that's what works for you and you want to label -1, -2, -3, -4, -5, -6, -7, that's fine. When I'm grading these, I'll be looking for your -4, your -1, and your -7. I'll be looking for the center line and your high and low points. Okay, my period is 2 pi. So that means I want to label from 0 here at the y all the way out to 2 pi. When we do these graphs, I try and have you break them in fourths. Okay, that will kind of get all the pieces you need. Now, I'm going to make 2 pi be most of my graph. Is how I do this. Because I'm only requiring you to graph one cycle most of the time. So if I make most of my graph 2 pi, what is in the middle of 0 and 2 pi? Pi? Because the middle of 0 and 2 is 1, right? So the middle of 0 and 2 pi is 1 pi. So I'm just eyeballing that. And I'm trying to put pi in the middle. Now, I said I want 4 pieces, right? Right now I have 2 pieces. I have 0 to 1 pi and 1 pi to 2 pi. What's in the middle between 0 and 1 pi? What's my middle point between 0 and 1 pi? Pi over 2. Because the middle of 0 and 1 is 1/2, right? Tack on a pi, and that is 1 pi over 2, or in other words, pi over 2. And then what's the middle between 1 pi and 2 pi? 3 pi over 2. Or in other words, what's the middle between 1 and 2 is 1/2, which is 3/2, 3 pi over 2. Okay. That's half the battle right there. The other half of the battle is getting the graph on here. Now, what does a sine curve do? It starts at the origin, which is still kind of the origin, except technically it is at 0, -4, yes? And then what's a sine curve do? It goes up. It's going to go up, and I kind of like to put some marks here, and I'll connect my marks in the middle. And it's going to have a max a fourth of the way through my period, right? So I'm going to have a max above pi over 2. Halfway through, so which is pi, I'm going to have what I would call a 0. So I'm going to cross through at pi. 3/4 of the way through, I'm going to have a minimum. Now, notice this minimum is under 3 pi over 2, and it's down at the level of -7. Did I mention the max was at the level of -1? I don't know if I mentioned that or not, but I need to. And then where does the sine curve end? It ends back at the x-axis, so at 2 pi. So as I go to draw that curve in, now I'm basically connecting the pieces, but that's what I'm trying to look for. I guess I put 5 marks, because I'm taking that graph and breaking it into my 4 pieces. And so I'm going to start here, go up here, go down here. Technically, my graph keeps going on and on. It doesn't stop there, so technically there are arrows. That's a sine curve. Questions I can answer. Okay. That's probably a good stopping point, because otherwise we're just going to get caught in a weird spot in the next one, aren't we? So on Monday, I would think we'd have a full day in here. We will continue, and we will practice a few more. I'll be honest, there's 6 total examples. I don't normally do all 6. Normally, as long as I can get through at least minimum 4, that, gives us a little bit of a variety. It just usually kind of depends on timing and all of that. Like, for instance, we got shortened because of a 2-hour delay. So